recently revealed what the blue light from our screens really does to our bodies. Do you leave your PC, Mac or TV on in the bedroom, as you drift off to sleep each night? Millions of people do without understanding the dramatic health consequences. These wonderful devices changing our lives are all the rage. Yet they all do something which causes harm in humans. The blue light they emit impairs restful sleep. How? Exposure prevents the release of melatonin, an essential hormone associated with sleep. Unfortunately, blue light not only suppresses melatonin production in sleep. It's considered carcinogenic pollution. A recent Murine study shows blue light correlates with higher cancer rates. A lack of melatonin is linked to higher rates of breast, ovarian, and prostate cancers, while blocking blue rays with amber glasses is linked to lower cancer rates. Not only is sleep impacted, it also negatively influences thermoregulation, blood pressure and glucose homeostasis. Exposure significantly impacts your own mood. Lower melatonin in mice is linked with higher rates of depression. And blue light exposure may be playing a role in the higher incidence of cataracts and macular degeneration seen today. How your sleep is compromised. Ordinarily, the pineal gland, a pea-sized organ in the brain, begins to release melatonin a couple of hours before your regular bedtime. The hormone is no sleeping pill, but it does reduce alertness, making sleep more inviting. However, light, particularly of the blue variety, can keep the pineal gland from releasing melatonin, thus warding off sleepiness. You don't have to be staring directly at a television or computer screen. If enough blue light hits the eye, the gland can stop releasing melatonin. The health consequences can be chronic and terminal. Not only does this impact melatonin, a growing body of evidence suggests that a desynchronization of circadian rhythms plays significant role in various tumoral diseases, diabetes, obesity, and depression. So light serves as a cue, but how? It has long been known that the retina contains two types of photoreceptors, or light sensors, rods and cones. The cones allow us to see colors, while the ultra-sensitive rods are used for night vision, motion detection and peripheral vision. Surprisingly, neither of them is the body's primary tool for detecting light and darkness and synchronizing our circadian clocks. There's a third kind of sensor in our eyes, officially discovered in 2002. Called intrinsically photosensitive retinal ganglion cells, or IPRGCs, these relatively crude sensors are unable to pick up on low levels of light from a dim night light, for example, but sluggishly signal light changes. IPRGCs are the body's way of sending ambient light information to the master circadian clock, a huddle of nerve cells in the brain. This clock makes the pineal gland start and stop the secretion of melatonin. The IPRGCs are most sensitive to blue light, that's why blue light is bad for your sleep. So now you know. There's hope. A study from 2013 found that people who spent a week camping in the Rocky Mountains, exposed to only natural light and no electronic devices, had their circadian clocks resynchronized with the rise and fall of the sun. Interestingly, although there were only 8 campers, they all reacted in the same way, whether they considered themselves early birds or night owls. Good news, you don't have to give up your device. There are other ways. For instance, one way to counteract the effects of tablets' blue light, Figueroa and Lockley recommend as a free app, f.lux, that automatically warms up the colors on your various screens, more reds and yellows, at sunset and returns them to normal at sunrise. The amount of light you need, in order to see, is lower than the amount of light you need to affect your melatonin, Figueroa said. However, avoiding blue light is just one piece of the puzzle in getting high-quality sleep that leaves you refreshed, awake, and energized. Check link in the description to get more.